Hello, welcome to the final chapter of the atomic structure topic. Today, we will be going through ions. So what are ions? Ions are atoms that have an overall electrical charge as a result of gaining or losing one or more outer electrons. As we learned previously, these electrons which are gained or lost are known as valence electrons. However, it is important to know that atomic number and mass number remain the same. Let me give you a more detailed explanation. For sodium, which is Na, it has 11 protons, 12 neutrons, and 11 electrons. To label this properly, these are protons, these are neutrons, and these are electrons. By the definition of ions, they lose or gain valence electrons. However, protons and neutrons don't change. So while number of electrons may go up or down, which you will soon learn is actually losing electrons for sodium, proton and neutron number remain the same. So atomic number and mass number will always remain the same. One other point of contention, which I think some students may struggle with, is that because ions have an overall electrical charge, they may ask themselves, okay, sure, you may lose or gain electrons, but doesn't that mean you can also gain or lose protons, but electrons remain the same, and that is why you have electrical charge? And to that, I would like to say this very important fact. The chemical properties of an element are actually defined heavily based on their proton number. If you were to change the proton number, let's say here there are 11 protons for sodium, if you were to lose one, it would become neon. It wouldn't be sodium anymore. Likewise, if you were to gain another proton, sodium would no longer be sodium, it would be magnesium. So just know that just because it's an electrical charge, you do not need to worry if it's whether protons or electrons change. It will always be a change in electrons and not the change in protons. To go deeper, positive ions are ions that are formed by the loss of one or more valence electrons, and they are known as cations. So a tip I have for you is cat has a T inside, and T looks like a plus or positive sign, so you know that cations are what you refer to positive ions. When writing the formation of positive ions, we start with the element symbol, let's say X, which will then form an ion due to a loss of the respective or the corresponding number of valence electrons. For instance, if we are talking about sodium, it would look like this due to the loss of one valence electron. So far, we've learned about valence electrons, valency, valence shells, and we've also learned about the electronic configuration. So today is where everything will come together. Since we are on the topic of sodium, and I use sodium in a lot of my previous examples, I shall continue using it so you have a better understanding and a bit more continuity. Ultimately, the goal of any atom or element is to obtain a stable electronic configuration of a noble gas, meaning that the outermost electron shell must be fully filled. Sodium, since it's a metal, will actually lose electrons to form or to acquire the electronic configuration of the closest noble gas. Sodium has a proton number of 11. Neon, which is a noble gas, has a proton number of 10. So this will be the closest the closest noble gas to sodium. And it has an electronic configuration of 2 and 8. Instead of gaining 7 valence electrons, sodium will simply lose that one valence electron, to obtain a stable electronic configuration of a noble gas. Because once the 1 is gone, all sodium is left with is a valence electron with a valence shell with 8 valence electrons. So it is fully filled, which is what sodium wants, since having a fully filled valence shell will make sodium stable. So that is why it will lose one valence electron to form an ion of a charge of +1. Even though it has a charge compared to the original sodium atom which did not have a charge, overall Na plus is stable, but Na is considered unstable since its valence shell is not fully filled. So using lithium as an example instead of sodium, we can see that the formation of positive ions, otherwise known as cations, occurs due to the loss of electrons. And how many electrons you lose is dependent on your electronic configuration. For metals like lithium and sodium, they will lose electrons such that their electronic configuration matches that of their closest noble gas. And this tends to mean that they actually lose all the electrons in their outermost shell. So if you use aluminium as an example, it's going to be 2, 8, 3. By rule of thumb, this 3 will be gone. So you're left with aluminium ion with a charge of 3 plus with the electronic configuration of 2 and 8. For further practice, the question is now asking you that a magnesium atom forms an ion. Write out the respective symbol and charges to represent the ion it forms. As a good rule of thumb, we shall first start with the atom. So magnesium is Mg, which is the symbol the question is talking about. You have electronic configuration of 2, 8, and 2. Magnesium ion will have electronic configuration of 2 and 8 instead. Since this 2 is lost, to obtain a stable electronic configuration of a noble gas, meaning that your outermost shell is now fully filled with 8 electrons, which is correct. The question wants you to write out the respective symbol and charges to represent the ion it forms. Essentially, the question is asking you to write this. So this would be your final answer. If you were to write it out in the similar equation that we learned earlier, it would simply look like this. Mg2 plus the loss of the corresponding number of electrons, which is 2 electrons. So that's how cations or positively charged ions work. Negative ions, on the other hand, are known as ions which are formed by the gain of one or more valence electrons, and they are known as anions. And explain for positive ions or cations, negative ions are formed by the gain of valence electrons only. It is not due to the loss of protons. So mass number and atomic number will remain the same. Negative ions are known as anions, and the symbol or the equation for their formation is as such. If we were to apply this to a real life example of, let's say, chlorine, it would mean that chlorine has gained a valence electron to form Cl minus. Since one electron is gained, the charge is now -1 or 1 minus. It's important to note when questions ask you for the charge, you have to write either -1 or -1 or 1 minus. Both are acceptable. If you were to look at a separate example, let's say that of oxygen, oxygen will instead gain 2 valence electrons to form a O2 minus ion. Negative ions are formed after gaining valence electrons, and here's another example in diagrammatic form. Nitrogen will gain 3 valence electrons to form a nitrogen ion. As mentioned earlier, the way we check the number of valence electrons that the non-metal atom will gain to form the ion is simply based on electronic configuration. Nitrogen has an electronic configuration of 2, 5, and neon is the closest noble gas to itself. Like metals, like sodium and magnesium and aluminium, they would want to obtain the stable electronic configuration of a noble gas, meaning they would want this 5 to become an 8, as opposed to the metals, which will simply just get rid of the outermost shell. The non-metals will actually aim to gain electrons. In this case, from 5 to reach 8, the nitrogen must gain 3 valence electrons, and that's how it goes from N to gain 3 electrons to form N3 minus ion. For further practice, a chlorine atom forms an ion. Write out the respective charge, symbol, and charges to represent the ion, which we did earlier. So if you recall, chlorine on its own is an electronic configuration of 2, 8, and 7. To obtain the stable electronic configuration of argon, which is the closest noble gas to itself, which is 2, 8, 8, it will need to gain one valence electron. So your equation will be as such, and the question is asking you to write the symbol and the charges. This will be your final answer, simply Cl minus. As you learn more about bonding in the future, you will realize that the electrons which are lost by your chlorine, for instance, will be transferred to such as your electrons which are lost from, let's say, your sodium will typically be transferred to, let's say, your chlorine. So your sodium is now positive, your chlorine is now negative, and the attraction between something positive and something negative, which is known as the electrostatic force of attraction, will cause your chlorine and your sodium ions to bond together to form sodium chloride. And that is an ionic bond, and sodium chloride is an ionic compound. It is actually your common table salt. But this will be more deeply discussed in depth when discussing bonding. All you need to know for now is mainly it is your metal atoms which form cations or positively charged ions, since the metals have a tendency to lose electrons, whereas chlorine and other non-metals tend to be the ones to form anions, since non-metals have a tendency to gain valence electrons and thus become negatively charged. Congratulations on reaching the end of the chapter and the topic of atomic structure. Hopefully you have learned something new. And like all things so far that we have learned, atomic structure is not necessarily very challenging, but it does form the foundation for a lot of other topics you will learn in the future in secondary chemistry. Remember to practice hard and to refine your skills such that your fundamentals are rock solid, and you'll be able to score very easy distinctions in the future.